correct?
Yes.
Yes, why?
Because the other one was an overall, so then 12.5.
Right. We originally estimated 12.5 and we knew that was slightly over. We ended up with a lovely 12, so we're pretty happy about that.
And we didn't estimate 12 earlier.
What's it doing?
Like when we got the 12.5, you said what it actually is, and we said 12.
Right. We didn't know that it was 12 though, yeah?
Yeah, I know.
Yeah, but now we're very sure that we've got a good calculation. You can use your CAS to do this stuff, right? I highly recommend if you're going to use the CAS to do that stuff, do not use the spreadsheet method. The spreadsheet method takes longer to write, it's easier to stuff up. Use the sigma notation.
Wait, spreadsheet method.
So as in your calculator, you know you can open up a spreadsheet, right? You can program that to put however many you want, and it will just read out all the x values, all the f of x values, and then sum them up, and then you multiply by whatever your h thing is. You can do that. It takes longer to set up, I reckon, and it's more prone to fat finger errors. Right, so I recommend that you use the sigma notation, either in Scratchpad or just in a normal sheet, because you can read the whole thing and make sure it makes sense, and it's not as easy to fat finger that because you can see it all there, whereas the spreadsheet usually goes over a page, so it's just a bit fiddlier. Either way, definitely use your CAS to do this. Right? Well, then you better get one. You should already have had one for 6 months. Yeah, you want to get CAS practice with that sort of stuff. Do it with things that you know what the result should be. So do it by hand, double check it, maybe use a scientific calculator if need be, and just make sure that you do correctly write things in sigma notation, and use the CAS to actually calculate them through. Okay? Yeah, 11A is pretty short, so you can use the CAS to just double play. Even though, so let me restart that. You do 11A the manual way, as normal, and then you can use your CAS to try to do it again, right, and make sure that your answers match again, because you already know what the answers are from the back of the book. So that's fine. Cool. Next thing. Oh, we didn't actually. Okay. Quick question. So I've got this. Are we all happy with that? What did you say? Plus C. Good. All right. Why did I need to put a plus C here, but I didn't bother to put one up there? Because they cancel in that. All right. So everyone's happy about that. Cool. Are these two the same idea? They're the same base idea. Are they called the same thing? No. Okay, what are they called? Cool. Why is it called definite and indefinite? Right, definitely it's between this and this. Indefinite means I don't know where it is. Right? You can also have improper integrals where you've got infinities involved, which can make sense depending on the context. It just reads as the limit as it approaches infinity. So that's good. One other thing. This is the indefinite integral. and indefinite. So, another warning for exams, sometimes it'll ask for the indefinite integral, or it'll just say the integral, and it won't give you terminals. Sometimes it'll say an indefinite or an integral. Right? If it says the plus c, if it says and, none. Okay? And that's really irritating, and I wish they wouldn't do that, but they do, so let me know. If it's the plus c and none. Okay? That's a pretty minor point, but it's just one of those things that it can cost you 1 mark and 1 mark out of 40 at the end of the year, 2.5%, just for whether or not you put on a plus C. Definitely worth knowing. Cool. Next bit. Okay, I want to integrate this thing, right, indefinitely. Can I do that? Probably. What would you get? What do you get?
So what was it? I have an n plus 1. X plus 1.
Cool. We're okay with that?
Yes. Plus 8. Wait, why do you do that?
I'm asking you. You've fallen for it, so that's why I'm doing it.
Well, dx.
Okay. The dx is that? Alright, fine. Cool. Are we all happy that that's definitely good? You shouldn't be.
Is it a line? Yeah.
The line things, if I had things here, then I would have the line there and I wouldn't need the C. So, let's, if I had, I can't use A now, Z, C. Oh, I can't use C. ST. So you'd have that and no C. Right. But that's not what we're doing. Yep.
Is that if A is equal to constant?
If A is equal to a constant. Oh, okay, I did assume that A was a constant, so hang on, let me put that in.
How would A not be a constant then?
It's a very
Yeah, it could be a function for all you know. But yeah, A is an element of the reals, so it's a number. There's another problem. Say again? Yeah.
They could be negative like 20, but they can't be negative 1.
Yep.
Then it goes
Now,
to 0.
Let's consider why. So, if we went, are we all happy that the A is just going to multiply out and not really do anything interesting? Yeah? Okay. So if I have x to the negative, let's go x to the 2, integrate that. I'm going to leave off all the dx's just to save space. Integrate x, integrate 1, integrate x to the negative 2, integrate x to the negative 1. Okay? I integrate this, what do I get? Try again. Try again. 1 and 3. Sorry?
Yes.
Alright, I'm going to leave off all the plus c's, they all happen to, yep. Negative. Okay, I'm getting 3 different versions of possibly the same thing, but you all mumble over the top of each other. Negative 1 what? Say again.
Negative 1 on x.
Negative 1 on x, cool, I'll take that, or x, negative x to the negative 1.
Yes.
Cool, either of those are fine. Alright, remember, we're increasing the power by 1. So if I start at negative 2, that goes up to negative 1. Yeah? Cool, what about this? Not undefined, but if we naively try to do this, we'd end up with, that's 0 times x to the 0. Does that seem like a problem?
No.
No?
No, it wouldn't be. It is wrong, isn't it?
Okay, right. What's that equal to?
0.
0, presumably, so long as x isn't 0. We'll get rid of that. So this is 0, cool. So that means if I derive 0, I should get this? No, right? So clearly this can't be right. Yep. What should be dividing by 0?
Like A divided by A divided by 0.
Oh, sorry, yeah, sorry. One of them is 0, yeah, sorry. So undefined, right? We've got a clear problem either way, right? So we need a way of dealing with that. Other than -1, is anything else going to stuff us? No. If I had x to the power of the square root of pi, would that stuff you up? No. It's a really terrible number, but you can still deal with it. It's just add 1 to it. Fine. It's only when we land back on 0 that we get this divide 0 problem. Cool. So that's why that exists. X to the -1 dx. These little reals. And now we'll ask the people that are doing special that should definitely have this easily memorized.
Isn't that how we
A times ln of, and I'm going to write it like that because there are methods on a special.
It's absolutely.
Right. If you want to be precise, should do that. In methods, it won't matter. They will always make it. They always fiddle with the question such that this expression, whenever they get you to do anything with it, it'll always be positive anyway. Because absolutes aren't on the state design anymore. That's that. Oh, plus C. Yeah. That's. So this bit was 11A, this bit is 11B, this bit is 11C. Oh, this one. Oh, sorry. Okay, move into stash.
不对啊，最后一个没有这样，对吧？你看过？这样过去之后不是挺打的？
Yeah, let's do it.
I don't exactly know, but I'm pretty sure it means all the correct
Okay. So, for example,
It's more like the term is aggressive. It's just like how that it's like I'm not aggressive. It's more like it's like very aggressive.
cool. So that's the general rule, which, so if you're doing special, that should look nice and familiar. For methods, it will, I'm pretty sure it only holds for when this is a linear function down the bottom. I think that's the only time you get it. I don't think they give you quadratics or anything else down there because that very quickly wanders off into special. Oh, wait. Oh, I haven't covered that. That's no problem. Yeah. Yeah. I think that covers all scenarios. As a general rule, if you do one of these and you're not sure if it's right or not, and obviously you don't have the backup book to check in an exam, what should you probably do?
Estimate.
No?
Put it in house.
No. Exam 1. If you're in exam 1, right, and you try to integrate something and you're not sure because it doesn't have terminals. Right, so if you're doing one of these and you're not sure whether or not it's right, there's a way that you can check.
You can derive it.
Right. If I integrated it, right, and then I derive it, where should I end up? Right, back where you started. So unless you manage to stuff it up in perfect reverse order, right, if you integrate it and then derive it again and get back where you started, you high confidence, hopefully. Right? If you manage to stuff it up in just the right way so that it cancels itself out and you magically end up back where you started, I can't help you because you're so prone to error that we're done. But yeah, so whenever you integrate something, is it usually easier to integrate or derive? Derive, like Mars, right? So pretty much always, whenever you integrate, you should probably derive really quickly just to make sure it goes back the way you expect. Beautiful. That's that. Questions, queries? No, we're all happy? Cool. Okay, how about it? Yep. Oh, this is special stuff?
Yep.
Okay, wait, let me stop this.